Hello viewers, today we'll learn about response of second order system for unit step input and under damped case. As we all know, the standard form of closed loop transfer function of second order system is C of s by R of s equal to omega n square by s square plus 2 zeta omega ns plus omega n square. And for an underdamped case, zeta is in between 0 and 1. From the earlier session, we have arrived with the roots s equal to minus zeta omega n plus or minus j omega n root over zeta square minus 1. And this omega d equal to omega n root over 1 minus zeta square. This is damped frequency. Now this also we have done in the earlier session. So we can replace this roots with minus zeta omega n plus or minus, replacing with this, that would be j omega d. Now, you're talking about unit step input. So, obviously, R of t equal to 1. That is nothing but, in terms of S domain, C of S, the response from here. That is, taking R of S that side, that would be nothing but 1 by S into omega n square by S square plus 2 zeta omega n S plus omega n square. By partial fraction expansion, this would be A by S plus BS plus C by S square plus 2 zeta omega ns plus omega n square. Please make sure that you would brush up with the basic fundamentals of partial fraction expansion before solving all this. Now, here we are supposed to get the coefficients a, b and c. For a, is nothing but c of s into s for s equal to 0. C of s is this one, omega n square by s into s square plus 2 zeta omega ns plus omega n square into s for s equal to 0. So s is 0 here, 0. So we are left with omega n square by omega n square. That is nothing but 1. This is A. Now for solving B and C. For that, omega n square by s into s square plus 2 zeta omega ns plus omega n square. A is anyhow 1 here, replacing with 1 by s plus b s plus c by s square plus 2 zeta omega ns plus omega n square. Now here we'll cross multiply this and then equate the coefficients. Omega n square s square plus 2 zeta omega n s plus omega n square plus s into bs plus c into s. So anyhow denominator got cancelled here. You're supposed to equate the coefficients. Now to start with, we'll equate the coefficient of s square. We get 0 equal to, from here it would be 1 plus, there is one more term here, b into s square. So it is b is nothing but b equal to minus 1. Now equating the coefficients of s0 equal to 2 zeta omega n plus c. Now from this you get c equal to minus 2 zeta omega n. So C of s equal to 1 by s minus s plus 2 zeta omega n s square plus 2 zeta omega n s plus omega n square. Now from here we are adding and subtracting zeta square omega n square to the denominator of the second term in this equation. So that would be 1 by s minus s plus 2 zeta omega n by s square plus 2 zeta omega n s plus omega n square, adding and subtracting zeta square omega n square. Now this would be 1 by s minus s plus 2 zeta omega n by s square plus 2 zeta omega n s plus, taking this term, zeta square omega n square plus, taking this term, omega n square minus zeta square omega n square. This would be 1 by s minus s plus 2 zeta omega n by, this is a plus b whole square format, so that would be s plus zeta omega n whole square plus, this would be taking out omega n square common, 1 minus zeta square from this term. This would be 1 by s minus s plus 2 zeta omega n s plus omega n whole square. This you are replacing omega d square. You can rewrite this as s plus zeta omega n. You are just separating this part, s plus zeta omega n whole square plus omega d square minus, okay, zeta omega n. Anyhow you have minus, so s plus zeta omega n whole square plus omega d square. In this third term we are supposed to multiply and divide by omega d. That would be 1 by s minus s plus zeta omega n, s plus zeta omega n whole square plus omega d square. Okay, from this minus multiplying and dividing by omega d here, that would be zeta omega n by omega d into omega d by s plus zeta omega n whole square plus omega d square. This is C of s in terms of s domain. We are supposed to get the response in t domain. For that we are supposed to find out Laplace inverse. So C of t is nothing but Laplace inverse of C of s. Laplace inverse of 1 by s is nothing but 1. This would be e power minus zeta omega n t cos omega d t minus zeta omega n by omega d into, for this expression, that is e power minus zeta omega n into t into sine omega d t. Okay, from this 1 minus e power minus zeta omega n into t common, cos omega d into t plus zeta omega n by omega d is nothing but, as we all know from the earlier terms, omega n into root over 1 minus zeta square into sine omega d t. This got cancelled. Now you are left with 1 minus e power minus zeta omega n into t cos omega d t plus zeta by root over 1 minus zeta square sine omega d t. Now taking the LCM here, that would be 1 minus e power minus zeta omega n into t, taking this out common, 1 minus zeta square into sine omega d into t into zeta plus cos omega d t into 1 minus zeta square. Example, this is a right angle triangle, this is the theta say, this would be root over 1 minus zeta square. So obviously sine theta would be 1 minus zeta square, opposite by hypotenuse, and cos theta would be adjacent by hypotenuse, that would be zeta, and tan theta would be root over 1 minus zeta square by zeta, and theta would be tan inverse of root over 1 minus zeta square by zeta. Okay, with this data you can write this expression as 1 minus e power minus zeta omega n into t by root over 1 minus zeta square into sine omega d to t. Zeta is nothing but cos theta here, so cos theta plus cos omega d into t, where root over 1 minus zeta square is nothing but sine theta. Okay, that would be e power minus zeta omega n into t as root over 1 minus zeta square sine of omega t zeta. Now here, if you go for an underdamped case response for a second order system, the response would be oscillating before settling to a final value. Okay. Again, the oscillations will depend on the value of zeta lying in between 0 and 1. If you do find this video useful, please like, share and subscribe.